Okay, so question number 6. What is the Lewis structure for H3O+? So this is the hydronium ion. So first, let's write its total number of valence electrons. Hydrogen contains 1 valence electron, and there are 3 hydrogens, so we multiply this by 3. Oxygen contains 6 valence electrons, and also this ion has an overall positive charge, so we know we have to subtract an electron from our total electron count. So these two will be added, but this one is subtracted. So 3 plus 6 minus 1 is 8 electrons in total. So now oxygen is our central atom, since it is more electronegative. And then let's just draw single bonds to all of the hydrogens and count out how many electrons we've drawn so far. So each bond contains 2 bonding electrons, so we have 6 drawn so far. Since we need 8 valence electrons in total, I'm going to draw the last 2 on my central oxygen atom. So now from here, we can calculate the formal charge of all of our atoms. So formal charge is equal to the number of valence electrons minus the number of non-bonding electrons. So this is all of the lone pairs minus the number of bonding electrons divided by 2. So now let's calculate the formal charge of one of the hydrogens. Okay, so all the hydrogens are the same. They have a valence electron count equal to 1. There are no lone pairs on any of the hydrogens, so the number of non-bonding electrons is 0. And all of them have a single bond, so this means there are 2 bonding electrons. We divide this by 2. So the formal charge of all of the hydrogens is just 0. So they're all neutral. So now let's calculate the formal charge of our oxygen atom. Oxygen has 6 valence electrons, and there's a lone pair, so we have 2 non-bonding electrons, and there are 3 bonds to the hydrogen, 3 bonds to all the hydrogens. So we have 6 bonding electrons divided by 2. So 6 minus 2 minus 3 is positive 1. So we know that our central oxygen is the one that has the positive charge. So now let's see what the junior tutor said. A Lewis dot structure is a representation of an atom, ion, or compound that shows how the valence electrons of the atoms are distributed as bonds, lone pairs, and sometimes radicals. Drawing the Lewis structure of a compound may sometimes need some trial and error. However, we can follow some guides and rules in drawing it. Step by step, determine the central atom. Typically, the central atom can create the most bonds. Sometimes it is given in the formula of the compound itself. Step 2 is to logically arrange the atoms. Thinking beforehand how many bonds an atom can create can be helpful. And for atoms that follow the octet rule, the number of bonds an atom typically makes can be solved by subtracting 8 by the number of valence electrons of an atom. Yeah, that's another way of doing it as well. Step 3, we can connect our atoms, adjust if necessary. Step 4, check if the rules below are followed. If not, make the necessary adjustments. Step 5, redraw the entire molecule if needed. Hopefully you don't need to get to that point. And there's also some rules that we need to follow. Make sure atoms that follow the octet state strictly have 8 valence electrons. These are typically period 2 nonmetals. So we can have some cases where the element or the atom doesn't follow the octet rule. So some examples would be like boron or beryllium, where they can have like empty orbitals and still be like stable. Rule number 2 is to minimize the formal charges of the atoms if possible. Rule number 3, more electronegative atoms are given the negative formal charge if applicable. And lastly, rule number 4, make sure the sum of the formal charges matches the charge of the compound. So for our question, oxygen is more electronegative than hydrogen. So usually it wouldn't be given this positive charge, but in the case of hydrogen, since there's only one electron, or since there's only one valence electron, then it can't just like lose it since it's participating in the bonding. So this is why the oxygen would still carry the positive charge because it's bonded to 3 hydrogens. And then rule number 4, make sure the sum of the formal charges matches the charge of the compound. So again, we just have the one positive charge, so we're all good. And then they apply these guides to draw the Lewis dot structure of hydronium. Oxygen is the most logical central atom, since the hydrogen atoms can create one bond only. And then they drew the possible arrangement. And now they fulfill the octet state for oxygen. We must add one lone pair to the said atom. Okay, so they just double checked all the rules. And they showed the equation for formal charge. Okay. And the charge of the entire molecule matches the formal charge, and they got the same Lewis structure. So this solution is correct.